Hey there again. Somebody had a question on video number 2. They said, hey, what happens when the peg isn't perfectly round? I made these images and I made them as straight as I possibly could. They're printed out on a computer and the center line is right in the middle of it. The sides are straight. It's all nice, perfect world, theoretically perfect. But what happens when this peg is rounded? It's like the shape of a banana. My pin is bent. Well, let's see. If we go back to the principle of this virtual boundary here, then we said, okay, this is like a dart, and the dart hitting the bullseye in the dartboard. But we slice the dartboard in half so that we can see that it actually has thickness, and the center line has to stay in there so that my peg doesn't violate that boundary, even if I'm all the way over here, as long as my center line stays in there. Okay, so if I bent this pin and I'm all the way over here and the thing was bent like a banana, it would start to violate this boundary, wouldn't it? And same thing over here. If it was bent like a boundary or bent like a banana, the middle of it would start to stick out there. So what are we going to do about that? Well, the people who came up with the GD&T, geometric dimensioning tolerancing standard, came up with a really brilliant, simple solution, and it's the basis for this whole virtual condition boundary concept. And what that is, it's called perfect form at MMC. And that may be confusing, but it's way simpler than the description of the text inside the standard, in my humble opinion. Basically what it says is the biggest, when your pin gets to the biggest size that it can be, it has to have perfect form. It has to be perfectly straight. It can't be bent like a banana. And the reason for that is, let's bring in our bent pin. So I have a pin that is bent, but I'm keeping it inside of this perfect form boundary. Let's move that over there. So my pin can be bent. It could be an hourglass shape. It could be any shape, have bumps on it, divots in it, whatever you want, as long as it doesn't violate this perfect form boundary. So we talked about in one of the other videos that this is what? There's no bonus tolerance on this like the other one. There's no orange region from this thing being less than its maximum donut condition, its maximum size. So keeping the center of our maximum boundary pin in there keeps us from violating that boundary. And the pin can go ahead and be a banana shape as long as it doesn't violate that boundary. So this is both you can think of this as a size and form sort of boundary. So as the pin gets bigger, the closer it gets to that maximum material condition, the more perfect it has to be. It can go. I could grab a marker. Here's a blue marker. I could grab this blue marker and just start filling in, making this pin bigger and bigger, or this dowel bigger and bigger, as long as I don't color outside that line. Okay? Because once it starts to stick outside of that line, again, let's bring our center line all the way up to the edge of the dowel. If I went outside of that line, guess what? I violated my boundary and the parts won't fit anymore. Same thing on the other side. That's why when I created this, I made the bulge go right up against that edge. So that is, if I were to grab my calipers and measure this pin, this is the maximum size of the pin, dowel, whatever you want to call it. That's the maximum size that's specified on the print. And if you are using, I think the way it's written in the standard is, if you invoke geometric dimensioning and tolerancing on your print at all, then these rules apply. So I could have a pin that says, hey, it's a 1/2 inch pin, or it's a 13 millimeter diameter pin, and its maximum size is whatever. Well, at that maximum size, even if there isn't a straightness call out on it or whatever, at that maximum size, it cannot violate that boundary. It must be perfect. And if you can't make it with perfect form, guess what? You better shrink down the size so that within all the bends that are in there, it doesn't violate that boundary. And when we do that, when we obey that rule, this happens to be called Rule 1, who cares? It's a rule. It's important that you know the rule, not what number it is. When you follow that rule, things will stay inside of the boundaries. They will fit. You follow your rules of position and size and your bullseye and what was the other one? And bonus tolerance, and everything will fit. Hopefully that helps explain that question. And yeah, see you in another video.